Okie dokie. Turn this on. All right. We're gonna check audio settings. Systems sound. More settings. Okay. Go to recording. Levels. Okay, it's 100% already. Great. So nothing has changed in my audio settings. That is cool. Close all the windows that I don't need. And boom. Oh, I have a resolve update. Oh, I'm gonna do it later. So what am I gonna do today? I want to work on the shaders, right? Ta-da! Well, let me update the title too. So that is going to be shaders management and everything that is adjacent to it. Yeah, why is it not this getting smaller? Okay, cool. All the windows are set. Shaders management. Let me start first on cleaning up my workspace by committing everything that I had been working on. So modules, what is all this stuff? Build blocks and break blocks. That's chunk generation. Oh yeah, this is a flipping of the face, a winding, and a bunch of stuff fixing the sRGB issue. And implementing the touch buttons. Yes, I think I'm still missing the grip and the trigger. I'm not sure if I have those. Yeah, I don't think I have them. Anyway, so build and implement build break blocks. that's it. It's not even finished, but add sync buttons for touch controller. Yeah, that's it. That should be everything. Yeah. Now let's quickly jump on the shader class. So solid flat is not really solid flat anymore. And it's more of a chunks render. It's a chunks shader. So, but what I need to do is moving most of the common code into somewhere else. So I'm gonna keep the shader class on the side. I'm gonna drink some coffee. By the way, I made some really yummy biscuits, cookies this morning. So let me scroll down to shader. This is the buffer. And this is the shader module. So maybe it's a good time to split those things. vk.shader. Yeah, this needs to be split into its own module. Yeah, let's do. Okay, check. Yeah, there's a bunch of things that I might need. This might not be very useful anyway. So no copy can be implemented by itself. I'm just gonna remove this. Let's see what happens when I remove it. Oh yeah, there's already something complaining about it. Let me see. Oh, where's my phone? No idea. How do you clear the notification on iOS? What the? Okay, notifications cleared. Oh no, mosquito. Damn it. Did I get it? Oh yeah, I got it. So make a new C++ modules IXX. I like CPPM. Oh, finally it's got CPPM. I'm gonna name it buffer. And we got buffer. Yeah, that's then also C++M. Wow, so many names. And then shader. We got the shader module. So this is going to be a vk.buffer. And this is a vk. How's the notation for arguments? I don't remember. Was it just one? Cannot find primary module interface. Aha, so it's a partition shader. Should I use partition? I don't know. And this is a whole module. Oh, that is a partition. So we have buffer and shader. All right, so we have buffer and shader, and all I need to do is to add it to the list of things to build. So then it's going to be buffer and shader. Once we get that, no prompt for updating. Okay. Oh, okay, it's doing it finally. So once you're done, I can start moving this bunch of code all over to the other module. So this is for the buffer. Buffer export name namespace vk Okay. So it's missing a bunch of headers. I probably need the context too. Or if this is just a fragment. No, this isn't gonna. Yeah, it is gonna need VK. Well, let me first copy all the things that might be useful for this guy here. That's going to be, well, on the old includes probably. Oh, module. Forgot. Module. But it's still missing. Import ca.vk. Okay. ca.vk. What is the problem? Context is in vk. It's now ce. That's ce vk. Okay, it makes sense now. Can I just, so this is a fragment with this imported? Not really. Okay, no problem. I'm gonna keep it like this for now. What's missing? Utils. Okay, it also needs utils. Nice. Local variable, what's the matter here? I have no idea. What are you complaining about? Okay. Then let's move also things to buffer. But I need to copy everything, yeah, up to this point into, oh wait, shader. Okay. So this is going to be shader. And this is all good. New line. And we'll bring over all the shader stuff. And boom. We have it. Just missing platform. I see. Platform, get platform. Where is get platform? Maybe you can suggest me where to find it. Huh? rc dot app dot no platform. Yeah, is that it? No. Globals, maybe. Okay, it was in globals. Cool, that's shaders module. Now, there should be some more breaking points. Yeah, especially here. So it cannot find it. You will find it in shader. This is what you were missing. That's for shader. What about buffer? Nobody's gonna complain about the buffer missing? Oof. Let's see. Maybe it's the next complaint is coming. Yeah. Ooh, okay. This has lots more. Import it out. So this is missing buffer. That's one class. Then who else is missing it? Oh, it's all grid. Grade. Is it just grade? That's impossible. Oh wait, still missing something. Oh, it's missing VMA. So this is including, oh wait, bulk but not VMA. So this doesn't export VMA. Yeah, that's not great if I have to import it. That is leaking. It's leaking API. Fatal, use of walk, need to define VMA, no prototype. What? Oh, because this guy needs to happen before. Or not. I don't even need bulk here. Okay. So now cube. Dear cube is missing buffer. Import c.bk.buffer. And that's it. We also conquered cube. Now chunk mesh is missing. Chunk mesh got buffer. And of course, the main application. It was missing buffer, but also shader. And we should be good to go. Ooh, wait, what? VMA already defined? What? Ooh, already defined in VK. Wait. So implementation shouldn't happen everywhere, right? Shouldn't definitely happen everywhere. We need We need it to happen on its own file, which doesn't need to be a module. So we can just call it as a regular vma.cpp. And that's it. Add it. So vma.cpp will define VMA implementation. So VMA implementation will have to use Vulk, fluid Vulk, and include vk memalog. And define. This will be added here. Good to go. Object, I don't know, maybe I can add it here to the list of these other files anyway. Yeah, it might even work if I add it to the modules. Okay, it's looking good. It is working. Very nice. Task completed. And it's everything's still working good. Breaking stuff. Yep. We can break. Can we build a beer? Yep. Build. We can fly away. That's it. Let's set a checkpoint. Okay. And that's done. Now, back to the shader. So we have the set layout. And this is very much linked to the shader, because it can have more than two. But the rights can be moved into the shader module. Oh, by the way, I'll call this shader module, but this is meant to be the Vulkan shader module. Anyway, so this can be moved upstairs. I'm gonna move it to the base class and as well as the scripture pool. Yeah, let's move it to the base class. You can finally promote. So the create layout, this will happen in place. It's got a bunch of custom things. Create a scripture set, blah, blah, blah. Push const. Yeah, I can remove the push const. Let's get rid of the push const, as well as from the shader. Wait, what's this? Yeah. CD. By the way, that was completely wrong. This is not very useful. Maybe, yeah, maybe as a shader manager. Shaders manager. It's probably gonna need import c.vk.shaders. So you, my friend, don't need the push buffer anymore. Because it contains draw index. But instead I'm using basic vertex offset. So that is everything into single vertex buffer with offsets. Okay, let's get rid of that. Per object arguments. Not using this anymore. Well, we have never used it anyway. And then no, to the HLSL code. Let's get rid of this guy. Per object argument. We don't have that. And that's it. Input color. I'm using the color as a UV, which is odd. And can optimize that. Yeah, that's an optimization stage, which we don't want to do it now. Now, per object args, this doesn't exist anymore. Per object args, yeah, this doesn't exist. And you get only one. Let's see. So that was another Another storage. Yeah, there was another storage. Another storage which, when I'm creating the poles, only have one storage now. Okay. Let's see if it's still working. Then we can promote the rest of the functions. Doing a bit of optimizations here. Cool. Okay. So it is still working. Travel to sector. Okay, nice. So this is the creation of the pipeline. The creation of the descriptor sets. We got the creation of the poles, which is also custom to the shader. Poles count, poles sizes. Let's suppose sizes. Sì, non vedi quanto è buio. First reset. So these can be moved. Ricordi. Wait, what? Something's wrong with indentation. Oh, because this stupid class here is indented. Yuck. You shouldn't be. And now this will also be indented. Okay, I can fix that. What? Wait, something is wrong. Okay, this is only one line. Set layouts. Allocate descriptors requires set layout. Okay, there is a bit of a clash here. Okay, this is an array. Maybe I can set it as a vector. Where is this created? 0 and 1, but they will be heap allocated. I don't know how many sets will ever someone need. Can I just set them to 8 something? Set layout size. Okay, now this is it doesn't matter if it's on the heap. Who cares? It's going to be a vector. And it doesn't need to be initialized with values, but here, yes. Sets. Wait, what's wrong now? Sets layout. As it is protected. What's wrong? Protected field. Yeah, that's fine. Oh, weird. Okay, now it's got it. So I just need to resize it to 2. Okay, now it's a bit leaner. We have the pipeline, and these functions can also be moved. Pipeline and the layout, all parent. Virtual constructor. Wait, does it have it already? Maybe I missed it. Oh yeah, it has it already. So it needs to destroy these objects. I can do. Yeah, let's do a test. Oh. What's oh, not protected. Needs to be public. Okay, makes sense now. Count. Well, this maybe can be moved to the parent. He's going to load the files. Yeah, that's the fair amount of boilerplate. What's wrong with this? Input is only assigned but never accessed. You kidding? It is accessed. What is this? What is that? Yeah, it's gone bonkers. It's gone bonkers. Create. No, let's try to create two variants of this guy. One So when I create the pipeline, I'm gonna pass in if it needs to enable blending. That's going to be a constable enable blending. I want to see blending here. Enable blending. Line. Okay, now this compiles correctly, and the creation say through. when it's water. A, B, C, D. A, B, C, C. And C, D to A. They're all gonna be 0.5 float. Let's see. Everything else is opaque except for the water. And okay. It's gonna, okay, it's not context blur. That's fine. We can live with it. Oh, what? Oh, okay, because we're doing the additive thing. Yeah. Not. Oh, look at the look at the drawing order being recomputed. Well, now we are drawing front to back, but instead but that's good for opaques. So opaques do good in that area. Now let's go back to the app where the draws are generated. So here we're getting, okay, this guy is generating chunks, and okay, so this is appending all the meshes. But instead we want to do all the opaques first. And then all the transparents later. Which isn't... let's get rid of that code. So that looks like... So everything is kind of the same. Video is okay. It's the same vertex buffer or not. No, this is sub-allocating buffers on the go. So we don't need to do this. It's not going to generate. Well, this is generic, so it could have some value. Given different layers, yeah, we can have trees and stuff into different layers. So what happens is that for each mesh, how we decide what mesh is what? Chunk mesh, block type. Okay, there's oh, it's divided by block type. I see. Oh, it's divided by block type. That means we can bulk render based on block type. Well, it shouldn't be even block type. It should be something else. We don't want to divide it by block type. That could be block layer. Block layer sounds a better way. So whoever generates this mesh needs to be updated. And I think it's this guy here. So where's the return? So the return mesh is returning based on the block type. Yeah, and so blocks are based on the block type, and the type is so blocks, but first this one is generating blocks type based on block type. These are the blocks. Okay, this is chunk data. Then the chunk data data.blocks. Oh, okay, that's blocks. That's the block, not the whole data type. That's fine. That's we get that. And it's emplacing it. Okay, so this is where it is creating based on the type. But instead we should have a function that maps types to layers. Anyway, we have just two types for now. So I'm gonna proceed with the dump version. So given the mesh type, We're not doing the merge. We will just check for each mesh if vertices is empty. No. So if it's empty, we just continue. We don't do the VBO thing anymore. Yeah, we will add to the polys, that's fine. If chunk is dirty, well, let's move that up, because that should happen before we do this computation. Okay, if that's the case. Now this goes even one step over, and then this is going to be vertices. And what changes here is VBO vertices. So we should have a draw count. Selected false, object color, a UBO pushed, which we're not even using anymore. So let's put this on a diet. We remove the color, which we are not using anyway. And so we invalidate this constructor, and that is good. So we are now pushing a UBO. But we should do that only for the batch. So the batch, we need two batches. Come on, batch. So we get the batch. Oh, we already have a one batch. This batch here is going to be for the opaques. And what one batch for translucent, transparent, whatever. And it's going to be at most the chunk size. The draw arguments, though. Where are we doing the draw? You're gonna need two draw arguments. And the draw count. Do I even need the draw count anymore? I'm not using the draw count. Oh yeah, we're using it. Okay, we have the draw argument for the opaque. We could structure this on a per layer thing. Current layer. It does all of that. But we need to change. We need to change the binding, the pipeline. So that's why it can't be done all at once. So this is a draw argument, and let's try to do the opaque thing here. And then the transparent. The draw count for the opaques. Draw. And the transparents. Well, this could all be encapsulated in a single structure, right? Like this is getting out of hands. I can see already. What if I create a batch structure which has UBO, the arguments, nice. Draw, well, I'm gonna start it here. Struct, batch, draw. And that's gonna have a UBO draw arguments, draw count, and that's it. So we can get rid of this stuff. And say we have batch throw, batch, for each block type we have a batch throw. So what is this doing? It's allocating the buffers. So we don't need the buffer. But we need the UBO. Destination, copy buffer, chunk buffer. Okay. So the chunk has its own buffer, but that is not correct. Because then again, it may have more than one buffer. So remove the old buffer, and the buffer, it's going to be by type. So that's going to be buffer and type. And the type is the mesh dot. Ooh, wait. Oh, that's the key. It's the key. Okay, we have the key. We can use the key, chunk buffer, and use the key. That's it. So we have that. And you can remove draw count. So then we can also push the transform for that guy and increment so that will be all here. instead of the UBO, go to the batch for the key dot UBO and push that. Cool. And that's going to be buffer key, and the draw args again, batch key dot draw args, and the VBO dot size, that's going to be m dot vertices dot size. That's a vertex count. And the batch key draw count, and we increment that. The draw count doesn't make any more sense. Oh yeah, buffer. So for each chunk, or if it's not dirty. Wait, why? Why only if it's not dirty? Yeah, that's weird. Anyway, for auto buffer in that's going to be key and buffer, and that's gonna be a reference instead of buffer, and it will be b dot buffer, which no, it's just buffer. It just b. Cool. That is sorted. Don't need this anymore. Now, for loop for each chunk, now we transform this into a for auto ref and that's going to be the block type key and the batch into batch, the key and the batch into batch. We need to count. So we need to keep these things around. No, shouldn't need it, but it also doesn't hurt too much. So that will be batch u size, and this is going to be a const. I'm going to const this. Oh yeah, chunk state. So we are using chunk state. It's a uniform buffer and throw args chunk state. So chunk state. Just make it a map at this point. That's going to be by block type and chunk state. So that's going to break everything in here. And clear chunk state. That's easy for auto ref const auto ref chunk state. Break it down into okay. That's fixed. Chunk state and then set by the key. So for each key, we do that, and the chunk state will also hold the draw count. Yes, why not? Otherwise, no. Draw count. What the? Draw count. So if I press enter, okay, it picks the one that I'm looking at. Row count is going to be batch row count, okay? And this also needs to be keyed. What is left? For const auto ref state in chunk state. That's going to be key and state. Row count. And that's it. Holy cow, I have no idea what's gonna happen. I'm gonna run it. And I just hope nothing crashed. Oh, it's not even compiling. Okay. What did I miss? Wait, what's this? Where am I? Okay. Okay, sorry, flat right buffer. Okay. Descriptor set. We forgot that. The descriptor set. The per frame can stay there, but this guy needs to be moved on a state based. Okay, and now I can fix all the things. So when we are here, we allocate a set. Allocate descriptor set. Allocate a descriptor set. For ref key state and chunk state. And then we can say state dot. It's const. Oh, let's remove const. So that's state, that's state. And here you get it from state. Mine state, no, nope. The M was supposed to come stay here. And we get the wait. How did I set this? Wait, let's go back in time. How did I set this? Uniform buffered off. Okay, yeah. It makes sense for each state. Makes sense. Let's go debugging so I can if it ever compiles. Oh no, it doesn't even compile. Okay. What's the matter now? Oh, it is not a member of an order. Why did I use that? What? Where am I? So we are doing the barrier. We need more than one then. We need the vector of barriers. It can't be const. So that's going to be a vector of barriers. And again, 4. This time is const. We're gonna break it into key and state. And you know which one. You're starting to learn. Pretty good. And at this point, that's going to be state. Okay, I can just address it like this, and barriers now can be used. Oh, okay. Now wait. That's dumb. What are you doing? This needs to stay here. Then we are just pushing Well, we technically know how many. So let's reserve. Nope. Let's reserve chunk state size. Okay, good. And back to here, barriers. Needs to be barriers. Yeah, this guy. Barriers dot size, and probably gonna complain about the type. And the barriers dot data. Cool. You have everything. Don't keep complaining. I'm getting hungry. Oh, hey. Hey, Ashish. Doing well. Yeah. We're doing great. Things are going as planned. Even though I'm just running out of time now. Okay, that was something. That was something. What did I just witness? I'll try. What happened here? Where did you break? Okay, in sub allocation. What just happened? So just drawing and then crashes. Okay. That's interesting. Very far away from what I was trying to achieve. Very, very far. Batch. So this is batch. Maybe I need to clear out the state. That could be. Now, what are you doing? So chunk state clear. I don't know. I'm just guessing at this point. Not yet. Oh. Well, it didn't crash at least. This time it didn't crash. But then, why are you drawing only one at a time? So we generating a batch. This is the batch, and each batch has a UBO. The vertices. So the chunk dirty false. Okay, so we're clearing the flag. That is good. If it's dirty. And if it's not dirty, we are not drawing it. That's why. That's why. Okay, makes sense. So we need to allocate a new vertex buffer only if it's dirty. That's why this was here in the first place. This guy, and it goes right here. right here. Okay. So at this point, if it doesn't have vertices, if it doesn't have vertices, we need to clear. So let's say this guy. He's annoying. Go away. You go away. So if it's dirty, then if it doesn't have vertices, we just deallocate. And there is no need, well, not just if it's dirty, but if it doesn't have, and it is allocated, then we clear it out and we say, okay, clear, 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 and continue. Yes, this should be the right way. Let's test it. So if that was it, should work now. Ooh. What? 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 What's happening? Oh. Well, what? I maybe shouldn't have a buffer. But maybe we can remove. Clear, no, not clear. But remove? How do you remove? How do you remove? Erase, erase. Erase key. Erase is really an ugly function name. Are you doing multi-view from single pass? Yes, that is a multi-view, and it's also doing multi-sampled from single sample. That's also an extension. No. Anyway, you can have a look at the source code. So if you're curious. So that is in the XR module. No, that's in the VK. that must be something multi-view. So you can see this is a multi-view thing. Oh, this isn't gonna work. I don't think I can fix it yet. So I will have to delay the fix till next stream. So it's in the middle of something. So now, right now, that's gonna work. This isn't gonna work. For every chunk we are doing, for every mesh, it's 30. Then do the send the buffer. If it's not, continue. And draw it. Oh well, anyway. See you in the next stream, where I will hopefully make it back to working. Bye bye.